Rohini College of Engineering and Technology from Department of Civil Engineering. So this is our civil engineering subject, 7th semester final year. So our subject name is CE 8703 Structural Design and Drawing. So I am Michael Devdure, Assistant Professor. So now we can see about the design for cantilever retaining wall. Then design for cantilever retaining wall. So example, so design a cantilever retaining wall to retain an earth embankment with a horizontal top 4 meter above the ground level. The density of earth is equal to 18 kilonewton per meter cube. Then angle of internal friction pi is equal to 30 degree. Then SBC means is nothing but safe bearing capacity of soil is equal to 200 kilonewton per meter square. Then coefficient of friction between soil and concrete is equal to 0.5. Then adopt M20 grade concrete and Fe415 HYSD bars. So now write the given data. Density of earth gamma is equal to 18 kilonewton per meter cube. Then angle of internal friction pi is equal to 30 degree. Then SBC of soil you can mention as the Q is equal to 200 kilonewton per meter square. So draw the diagram. So they will given only at the horizontal top 4 meter above the ground level. Okay, so just we have marked as the above ground level 4 meter on top of our retaining wall. Step number 1, dimensions of retaining wall. So first we find out the depth of the foundation. So is equal to Q divided by gamma into 1 minus sin pi divided by 1 plus sin pi the whole square. This is the depth of foundation formula. We know that Q is equal to 200, then gamma is equal to 18, then pi value is 30 degrees. So apply the values, you got the depth of foundation is equal to 1.2 meter. So just mark the values in our diagram. So above ground level we know that 4 meter. So below ground level is the depth of foundation, it is that 1.2 meter. The next be overall depth of wall. So overall depth of wall is equal to 4 plus 1.2. It is nothing but, so see the diagram, 1.2 meter is the depth of foundation and 4 meter is the above ground level. So add the 4 plus 1.2, we got the 5.2 meter. This is our overall depth of wall. The next, thickness of base slab. So it's a simple formula, is equal to capital H by 12. Capital H means overall depth of wall. So we know that 5.2 meter. So 5200 mm divided by 12. We got the 433 mm. So we can take as a round off value for 450 mm. So just mark the values in our diagram, 0.45 meter. The next, height of the stem. So small h. So height of the stem is a simple. See the diagram. So height of the stem means only taken as the vertical portions. So we know that overall depth 5.2 meter. Then thickness of base slab also we know that 0.45 meter. Then simple, 5.2 meter minus 0.45, we got the 4.75 meter. Then width of base slab, so b is equal to 0.5h to 0.6h. This is simple formula. So apply the h values, you got 2600 mm to 3120 mm. In between some of the values you can taken. Okay, suitable value will be taken. So the rounded value is 3000 mm. So we taken the 3 meter. So width of the base slab is 3 meter. So mark the all the values in our retaining wall. So our top of the stem portion we can assume as 0.2 meter. Then height of the stem portion is 4.75 meter. Then overall depth is 5.2 meter. Then thickness of base slab is 0.45 meter. Then width of base slab is 3 meter. So our toe slab distance and heel slab distance we can find out the, so assume the toe slab with this 1 meter. Okay, so assume the toe slab with this 1 meter. So remaining values are, if you know, you can easily find out the heel slab width. So step number 3, stability calculations. So see that retaining wall. So the vertical portion we can name as the W1, and the horizontal portion, the slab portion, we call as a W2, and our soil portion we called as a W3. Okay, so the now we can split the vertical portion. So the vertical portion is a rectangular portion or triangular portion. This is trapezoidal portion. So we need to split that one rectangular and remaining one is triangular. So split the, see the diagram, see the figure B, you can understand easily. So mark the values. Then stability calculation, then find load. So W1 is equal to B into D into gamma C, because one rectangular portion and one triangular portion is there. Then plus write the triangle area formula, 1 by 2 into B into H into gamma C. Okay, we know all the values from taken our code book. See the diagram, one rectangular portion, one triangle portion. This is W1 for. Okay, so first B is 0.2 meter, so apply the values. Then D is equal to height of the stem 4.75 and gamma C is the 24. Okay, then 1 by 2 into B into H, triangular portion also we know that B is equal to 0.25. See the figure B, our triangle portion base width is 0.25, height is the stem portion same position 4.75. So finally we got a 37.05 kilonewton. This is our W1. So next we can find out the W2. So W2 is the base slab portion. This also rectangular portion. So W2 is equal to, we know that area formula, B into D into gamma C. So B is equal to 3 meter and D is equal to 0.45 meter. So we got 32.40 kilonewton. The next W3 position. So B into D into gamma S. See the diagram. So above the heel slab, the soil portion is there. Okay, so that is a, we can assume this rectangular position. So we know that simple formula for rectangular position in area, B into D is the area formula. Then put the gamma S value, because that is a soil position, so apply the gamma S value. So you need to carefully apply that. In this portion you can apply only unit weight of soil value. Okay, so B is equal to 1.55 meter into 4.75 is the D value, and gamma unit weight of soil is 18. So you got it 132.50 kilonewton. Finally total load is equal to W1 plus W2 plus W3, 201.95 kilonewton. The next, bending moments at A, because we already find out the M1, I already find out the W1, W2, W3. Now we go to find out the moment M1, M2, M3. So moment value is simply, you know the simple formula, moment is equal to load into distance. We already find out the load values. Now we are going to find the distance also. Okay, so see that this is the figure A. So our W1 length is 22.80 into 1.65. This 1.65 is taken from 1.55 plus the rectangular portion divided by 2. One thing on your mind. So in our retaining wall, for any rectangular position, that will be length will be divided by 2. For any triangular portion, it will be divided by 3. This is a constant. Okay, so now we can 22.80 is the rectangular portion load. So you need to, our length is 0.2 meter, so divided by 2 you got 1.65. see the figure B, this is a triangular portion. So now 1.55 plus 0.2 plus 0.25 is the rectangular triangular portion base slab width. So 0.25 divided by 3, because these are triangular portion. So you got it 1.83 value. So finally 63.69 kilonewton meter. This is M1. The next M2. M2 is the base slab, simple W2 into length. So our base slab width is what? This is a rectangular portion. So this is 3 meter. So 3 divided by 2 is equal to 1.5 meter. So 32.4 into 1.5 meter is equal to 48.60 kilonewton meter. Next W3 value. Sorry, M3 is equal to W3 into length. So see the diagram. So W3 is the soil area. This is also rectangular positions. So 132.50 is W3 and length is the 1.55 divided by 2. So 0.78. So 103.35 kilonewton meter. So M4 is the moment at base from our starting. Step number 2, 107.2 kilonewton meter. So total moment M is equal to M1 plus M2 plus M3 plus M4. So our answer is 322.81 kilonewton meter. The next point of application we need to find out that Then Z is equal to sum of moments divided by sum of load. We know that sum of moment is 322.81, sum of load is 201.95, so Z is equal to 1.6 meter. Then eccentricity, so again simple formula for eccentricity, E is equal to Z minus B by 2. So Z is 1.6 meter, so B is 3 meter. So carefully listen, for this step only you will take a B is equal to 3 meter. So remaining all steps you can take B is equal to 1 meter. For eccentricity finding step only B is equal to 3 meter, because this 3 meter is width of base slab. Okay, so Z is equal to 1.6, B is equal to 3 divided by 2, E is equal to 0.1 meter. So we can one condition, so that will be E is less than B by 6. So now we can find out the B by 6. So B is equal to 3 meter, so 3 by 6 is equal to 0.5 meter. So 0.5 is 0.1. So this is hence safe. Okay, the next, maximum and minimum pressure at base. Okay, now we can find out the pressure. So sigma is equal to, it's a common formula, sum of load divided by B, then bracket 1 plus or minus into 6E divided by B. Okay, so total load is 201.95, B is the 3 meter. So you can sigma maximum is equal to 1 plus 6E by B, sigma minimum is equal to 1 minus 6E by B. See that, so our sigma max is the 1 plus 0.2, our sigma minimum is 1 minus 0.2. Okay, our maximum value is 80.78 kilonewton per meter square, the sigma minimum is 53.85 kilonewton per meter square. So this is our top view of our retaining wall. Okay, so the left side portion is the toe slab, and the center is the stem portion, and right side the heel slab. Okay, this is our retaining wall. You can imagination from top view of our retaining wall. Okay, so mark the values. Okay, our sigma minimum value is 53.84, we can mark the H portion, and sigma maximum is the 80.76. then you can given some names, A, B, C, D, R, P, Q, R, S, anything you can given that name, it will be there. Then now we can find out the stem portions, and so split into one given shapes, triangular shapes or rectangular shapes, the toe slab for two rectangular shapes and triangular, then stem also two rectangular and triangular, then heel slab also one triangular portion and one rectangular position. So next, step number 3, design of toe slab. So this is our retaining wall. So toe slab is the left side portion of that retaining wall. So our toe slab length is 1 meter, then below the depth of foundation is 1.2 meter, then above the toe slab some soil will be there, so that depth is 0.75 meter. Then first find load reductions. So self weight of toe slab WD1 is equal to, is a simple rectangular formula, B into D into gamma C. So B is 1 meter, then D is 0.45 meter, then gamma C is the unit weight of concrete, so we taken as a 24. Then we got a 10.8 kilonewton. Then self weight of soil over the toe slab. So see the diagram, so above the toe slab some of the soil it will be there, so we need to find out the self weight of that soil area. So self weight of soil over toe slab W2 is equal to B into D into gamma S. So B is equal to, we know that 1 meter, then D is equal to 0.75, so this is depth of the soil portion. Then gamma S is the 18, because that is a soil area, so we need to take as a unit weight of soil, so that unit of soil given in our question, so we got the answer is 13.50 kilonewton. Then next, find out the moments deductions. So md1 is equal to w1 into length, we know that simple. Moment formula is what, load into distance, we know the load, so w1 is equal to 10.8 into 0.5. so length is what, this is our rectangular portion, so we need to divide by 2, so 1 by 2 is equal to 0.5 meter. So 10.8 into 0.5 is equal to 5.40 kilonewton meter. Then md2 is equal to 13.50 into 0.5 is equal to 6.75 kilonewton meter. And finally we need to add that total moment deduction. So md is equal to md1 plus md2. So md1 answer is 5.40 plus md2 is 6.75, we need to add that, finally got that 12.15 kilonewton meter. The next, see the diagram. So this is our top view of our retaining wall, so toe slab, stem portion and heel slab. So now we can focus only on toe slab portion only, no need to see that stem and heel slab portion. So see the toe slab, so one rectangular portion, then again one rectangular portion, then last one K F L E, that portion is the trapezoidal portion. So we need to split into rectangular and triangular portion, that portions only. So we can easily find out the load and moment positions. Next, see the second diagram, see the figure B. So CDMF we have taken as the one rectangular portion, then EMF we taken as the one triangular portion. So simply we can find out the load and moment positions. So now we can find out the length of the values. Okay, so LF we don't know the LF, so we know the IG values, then JE values, but KE values but we don't know the LF value. So now we need to find out the LF value. So again I need to zoom the that values triangular portions. So GKE, then GKE, now we find out the LF. So up to 1.45 meter, our KE value is 13.02 meter. Okay, so what value for up to 0.45 meter for LF value? So it's simple, 1.45 divided by 13.02 is equal to 0.45 divided by LF. So LF is equal to 4.04 meter. We got that. Then upward pressure. So now we find out the upward pressure. So see the diagram, mark all the known values. Okay, so mark all the values. Now we can find out the CDMF figure. See that CDMF we taken as a rectangular portion. So we need to find the load value. So CDMF W1 is equal to B into D. So B is the 1 meter because CD toe slab length is 1 meter. So D is our 71.78. So finally W1 is equal to 71.78 kilonewton. The next, see that FME or MFE triangle portion. So we know the triangle formula 1 by 2 into BH. So apply the value, W2 is equal to 1 by 2 B into H. B is equal to 1 meter, then H is equal to 8.98. So we got the 4.49 kilonewton. Now we find out the moment value, CDMF. M1 is equal to load into distance. So load is the 71.78, distance is this is a rectangular shape, so length divided by 2. So 1 divided by 2 is equal to 0.5 meter. So 35.89 kilonewton meter. Then MD2 is equal to W2 into length. So that length will be triangular portion, so divided by 3. So 1 by 3 is equal to 0.33. So W2 is the 4.49 into 0.33 is equal to 1.496 kilonewton meter. So M is equal to M1 plus M2. 35.89 plus 1.496 is equal to 37.38 kilonewton meter. So bending moment M is equal to capital M minus moment reduction. So our capital M is 37.38 minus our moment reduction is 12.15. So we got the 25.23 kilonewton meter. So then factored moment M is equal to 25.23 into 1.5 is equal to 37.85 kilonewton meter. The next to find AST. So AST is equal to M is equal to 0.87 FY AST 1 minus AST into FY divided by BD into FCK. So this formula is already we know that. So page number 96 from IS code book 456 2000. So now we can apply the moment values. So remaining all the values are same. Okay. So now we can apply the moment values only change. So directly you can easily find out the using calculator x1 and x2 values. So take the least value. So ASD is equal to 265.7 mm square. Then as well as finding spacing. So provide 12 mm dia bars. So spacing formula we already know that 1000 into by d square by 4 divided by 4 divided by ASD. So D is equal to apply the 12 mm diameter. So finally you got the 425.65 mm. So our maximum spacing value is 300 mm. So we need to take as below 300 or taken at 300. So provide 12 mm dia bars at 240 mm center to center distance. Then find distribution reinforcement. It is simple. AST minimum. This is not a distribution reinforcement. We call it as AST minimum also. So AST distribution is equal to, this is a constant formula, 0.12 divided by 100 into B into D. So 0.12 divided by 100 into B is equal to 1000 mm into 450 mm is equal to, we got the 540 mm square. Now again we need to find out the spacing for distribution reinforcement. So spacing formula is the same as well as same as the main reinforcement. So D is equal to 12 mm, so A is equal to 540 mm. So we got a 209 mm, so rounded to 210 mm. So provide 12 mm dia bar at 210 mm center to center distance. Then step number 4, check for safety against sliding. So P is equal to Ka into gamma into H square by 2. Okay, so K is already known that 1 by 3 into gamma is 18. So H is the overall depth 5.2 meter. So all the values are you know. Okay, you directly apply the values. Our answer is 81.12 kilonewton. The next, factor of safety against sliding, one simple formula, the mu into W divided by P. So mu is given in our question. Okay, mu is given in our question. Mu is equal to 0.5. Then W is the 201.95. Then P is the, we can find the previously 81.12. So you got 1.24 value. So this factor of safety is less than 1.5. So this is unsafe. So since the wall is unsafe, so a shear key is to be designed below the stem. Okay, so sometimes the factor of safety is above 1.5, you can save for this slab. Okay, you no need to find out the shear key portion. So step number 5, design of shear key. So intensity of passive pressure in shear key front. Okay, so PP is equal to passive pressure, so KP into sigma max. So Kp is 1 plus sin pi divided by 1 minus n pi. We know that pi values, pi is the 30 degrees given in our question. So Kp is equal to 3. So apply the Pp is equal to Kp into sigma max. So Kp is 3 and Pp is pressure in shear key front. So our value is 71.78 is equal to 215.34 kilonewton per meter square. So passive pressure P is equal to Pp into A. So A is the width of the stem base. So Pp is 215.34 into 0.45. You got it. Pf is equal to 97 kilonewton. So factor of safety against sliding again need to find. So mu is equal factor of safety is equal to mu W plus Pf divided by P. So apply the mu is 0.5, the W is 201.95 plus Pf is we can already find it previous step. So Pf is equal to 97, then P is equal to 81.12. So this value is 2.4 meter. So above 1.5 meter. So hence safe. So minimum percentage of reinforcement shear key is equal to AST is equal to 0.3 percentage of cross section of area. So 0.3 divided by 100 into B into D. So B is equal to 1000 mm, D is equal to 450 mm. You got a AST is equal to 1350 mm square. So find provide 6 mm dia bar. So find the spacing. Spacing is the same formula. So D is equal to 6 mm, then AST is equal to 1350 mm. So our spacing is 148.9 mm. So we can take as a round of 150 mm. So provide 6 mm dia bars at 150 mm center to center distance. So step number 6, find shear stress. So shear force is V is equal to 1.5 P minus mu into W. This is formula. So 1.5 into P. All the values are you can already find it in our previous steps. So you can directly apply the values. You got the answers. So P is equal to 81.12. Then mu value is also known. W value is also. So finally answer is 20.7 kilonewton. Then factor the shear force V is equal to 20.7 into 1.5. So 1.5 is the factor load. So 31.05. Then shear stress tau V is equal to VU by BD. So VU is equal to 31.05 into 10 power 3 divided by B is equal to 1000, D is equal to 400 mm. So 0.077 Newton per m square. Then find tau C. So this is one constant formula 100 AST by BD. So table 19 page number 73 from code book IS 456 2000. So this formula in our code book. So 100 AST. AST is a we are find in previous step 1350. Then B is equal to 1000 mm. Then D is equal to 400 mm. So our value is 0.335 Newton per mm square. So in our code book up to 0.25 one value is 0.36, again 0.5 to 0.48. So our our answer is 0.33. So in between 0.25 and 0.5. So we can take as the average for 0.36 plus 0.48. We got a 0.42 value. So this is the tau c. Tau c is equal to 0.42 Newton per mm square. Our condition is tau c is greater than tau v. So hence safe. So reinforcement details. So this is our retaining wall reinforcement details. So mark the values, stem positions, then base slab position, the heel slab position. So taken from our previous steps. So our stem position, the vertical stem is 16 mm diabar at 300 mm center to center distance, then 10 mm diabar at 145 mm center to center distance. Then see the heel slab, our main reinforcement 12 mm diabar at 240 mm center to distance. Then our minimum reinforcement is 12 mm diabar at 210 mm center to center distance. See the shear key format 16 mm diabar at 140 mm center to center distance. So mark all the values from our previous steps. So see that longitudinal section. So mark the stem values and the base slab values. So simple diagram, you can easily understood that. So our shear key value is also 16 mm diabar at 140 mm center to center distance. Then stem values are 16 mm diabar, 300 mm center to center distance. Then our base slab values 12 mm main reinforcement using 240 mm center to center distance of spacing. Okay, thank you.